Hey guys, so we have a small cardboard box today to explain today's video, but it won't be too bad. I was just doing this in a couple weeks ago. I was just solving for areas of random shapes in my book that I do things in. And I figured out a pretty neat formula for the area of an insided polygon. And it turns out this is just the general equation anyway, but that's okay because I'll show you how I derived it. So, keep this out just in case. Sorry for the small cardboard box and sorry for the low video uploads. I'm moving out to college, so we're saving on cardboard boxes and I'm saving on time because I've been working a lot. But I should have an upload again. Like this will be my upload in 2025, last upload 2025. And then I should have another upload in like January 4th. But anyway, so solving for the area, let's do a hexagon because that's going to be the easiest to demonstrate this with. Oh, and I drew it wrong still somehow. It's a little not even. These are all supposed to be the same side length. And we're going to call this side length L. Okay? So, first, we're going to split up this hexagon into triangles. And there will be a center point here. So, for each of these triangles, we will have side length L, and then two side lengths X. For each of the, so it'll be 6 of these, okay? So, then what we're going to do is we're going to split this in half. We're going to bifurcate this triangle, split it in twain, tear it asunder, if you will. And that will give us X, Y, and L over 2. Oh, I should have the right angle. So, do we see here? X, Y, and L over 2. Which makes sense. Think about it. This is L. We took this triangle, split it in half, meaning that this length is L over 2, because it's L split in half. This is still X, nothing's been done to it, and then this height must be called something, so we just named it Y. So, now we need to find out this angle, and in order, let me see exactly what I did with the, okay, I thought so, that's how I did it. So, I mean, I'm just showing you why this is important for the area, because once we get this angle, we can calculate Y, and once we calculate Y, we can get the area by I'll show you, but this is important. So we need this angle, okay? We're going to call this angle theta. Okay? Theta. So, theta, we're going to have a general equation for it. Theta, we calculate this way. Let's draw a circle of 360 degrees around the midpoint. Now, we've just split this 6 times for the insides. Okay, so it's 360 over n. But we need this angle, which is going to be each of these split in half. So it's going to be 2 times n is going to be 360 over 2 times n is going to be this angle. Make sense? Because it's 360 divided by n and then split in half each time. So it's 2 n's. So then we have theta equal 360 over 2 n, which we can simplify this if we cancel the 2 out. So equals 180 divided by n. And since for a hexagon n equals 1, 2, 3, 4, 5, 6, then this would mean that is equal to 30. Yeah, 30. So yeah, 30 degrees is our theta for here. But we don't really need to calculate that per se like yet. So then, now we need to get y. And I know we could have gotten y by using the square root 3 over 2, I think is the equation, equals the side length. But this method was the way that I came up with, and I thought it looked prettier. So we're doing this method. So y is going to be equal to, so we're going to use tangent because it's opposite over adjacent. So tangent of 180 over n equals opposite, so L over 2 over adjacent, so L over 2y. So then calculating for y, we get 2 tan 180 over n, and then all that to the negative 1, right? Yes, and then times L. Yeah. Okay, so then now we have this height. Now, if you'll recall, it's the area of a triangle. Sorry, let me add equals y. That's the equation for our height of a triangle. Now, if you'll recall, the area of a triangle is just the base times the height times 1/2. So area equals 1/2 base, which is L over 2, times the height, which is going to be L over 2 tan 180 over n. Yeah. See how area is 1/2 base times height, and that gives us the area of this one triangle. And then we're going to there's 2 n of these triangles. Since we normally have n amount of these triangles, but we split them in half, meaning there's 2 times as many. That'd be 12 in this case. So we're going to multiply by 2n. So times 2n. And then we can cancel out the 2 and the 2n and the 1/2 at the beginning of the area for a triangle, leaving us with the area of a regular sided polygon of length L and amount of sides n as, let's see here, it'll be n L squared divided by 4 tangent of 180 over n. That's the area of any n-sided polygon. And also it works for triangles too, which is very cool. So then we can, and also if you want this to be, it can be pi. It depends on if you're doing tangent in radian or in degrees. If you're doing it in degrees, it's 180. If you're doing it in radians, it's pi. And so, yeah, it works either way. I'm not a math educator, so like, I don't know which, but it'll work either way. Like both of these give you the correct answer. That's all I'm telling you, okay? I'm not teaching you anything. Anyway, now here's an interesting thing. So first I was like, oh, it'd be cool is if we took the limit of as n went to infinity, but and then we'd get the area of a circle, right? But actually that does not end up happening because like if you think about it in your head, as n goes to infinity and L stays constant, we just get these, like let's say L is 1, we just have one length, all the way to infinity, and so you just have an infinite area. Because you can't, it's not like a fractal, you can't have like the finite volume or finite area and infinite surface area because it's meant to look like a circle, and so it must stack out. And so I was like, oh, that sucks. But then I fell asleep and then I woke up and I thought of this, which does work. If we set a perimeter equal to what did I put here exactly? I put interesting way I calculated that, but okay. I said that the perimeter of a circle, like of any shape, is going to be equal to the number of sides times the length of that side. And so then if we turn, we make length equal to perimeter over n, then we can sub this in. And if we make perimeter for a circle for let's say a circle of radius 1, okay, is going to be 2 pi over n. Then we plug that in, the limit as n goes to infinity, so as the number of sides go to infinity, of n times 2 pi over n squared divided by 4 tan 180 over n. I actually didn't know how to solve this limit, so I just like literally plugged in like near infinity numbers. And do you know what it ends up giving you? Can you guess? Pi. Sorry, God. Pi, because in this we put the perimeter is 2 pi because perimeter equals, or the circumference of a circle is 2 pi r, and if r equals 1, then the perimeter is 2 pi. But area of a circle is pi r squared, so if r equals 1, then it's pi times 1 squared, which is pi. So it can calculate the area of a circle by dividing it into a bajillion different triangles, and then summing the area for all of those triangles up. Isn't that so freaking cool? Math is so awesome. Let's see. We could do a little challenge to the viewers and try and calculate this using the method where we calculate y without using the angle, and instead we use the square root 3 over 2, the equilateral triangle type deal. Though I'm not sure if that'll work because I don't know if that square root 3 over 2 thing only applies to equilateral triangles or not. I think it might, so that would only work for hexagons, unfortunately. And it wouldn't be a generalized equation. You know what? I don't think it will work. So never mind, not challenge to the viewer because that might be an impossible challenge. But here's the final thing. And remember, this can be pi if you're doing it in radians, but it's 180 if you're doing it in degrees. So I hope you guys have a happy new year. I will be uploading a video very soon, like early January. Happy 2026.